The unit circle, radian addition. Objective: by the end of the lesson, you should be able to evaluate the 6 trig functions given a point, find the exact value of a trig function on the unit circle in radians, and given the value of a trig function at a quadrant, find the other trig functions. So we'll start with the first one. So in this problem, we're going to say the terminal side of an angle in center position contains a point -6,2, and it wants to find the exact 6 trig functions of that angle. So what's going on here is that they're giving us a point on the xy axis. So like this. And then it's at 6, -2. So honestly, it doesn't matter. We'll say 6, -6 and 2. So we'll say, I'll just do this. So now the way we graph our angle is super important. So -6,2 will be the point right here. That's the point -6,2. And we always draw our triangles the exact same way. We always go straight to the x-axis, then we go to the origin. Like that. That's the standard way we draw our angles of the terminal side. You go to the x-axis, make a rectangle, so always to the x, and you always go to the origin. This makes a right triangle. And good for us, we know the sides. So we went left 6. So it makes this side -6. We went up 2, right? So it makes this side 2. The angle we made, right? There's our angle, theta. That's always the one nearest to the origin. So that's this guy. What am I missing? Well, I'm missing the hypotenuse. We know how to find the hypotenuse. It's a right triangle. So if we want to find the hypotenuse, we're just going to do a squared plus b squared equals c squared. Where a is, remember the legs don't matter. One of these is a, one of these is b, doesn't matter. C has to be the hypotenuse. So we'll say 2 squared plus -6 squared equals c squared. I get 4 plus 36 equals c squared. So 40 equals c squared. Square root of that, I get rad 40. Or you could say 2 rad 10. I'm going to leave it rad 40 for now. So that's my hypotenuse. What do they want to find? They want to find the 6 trig functions. We'll do a couple of them. We're not going to do all of them for the sake of time. We'll do sine of theta. We'll do cosine of theta. I'm going to do tan of theta. Okay, so here's my theta, right? What's the first thing we always do? Label the sides. You don't have to write it down, but you at least do it in your head. Here's my angle. That makes this side opposite. Here's my right angle. That makes this side the hypotenuse. Which means this side is adjacent. It's also the one right next to the angle. That's the hypotenuse. Sine, we're going to do SOHCAHTOA. Whoops. So sine is opposite of hypotenuse, which in this case is 2 over rad 40. Let me rationalize. Cosine is adjacent to hypotenuse, so -6 over rad 40. And tan is TOA, opposite of adjacent, so 2 over -6. If you want to simplify, -1/3. And that's the idea, right? So in that point, you make a triangle, find out any missing sides, and then do SOHCAHTOA. So this is the exact same thing. So I don't think we're going to do all of them. We'll do a couple. So 1, 2. So here's 1, here's 2, right? So you draw a point there, 1, 2. Remember, we always go to the x-axis, and we always go to the origin. So there's my little triangle. And we should know these sides. Right, 1, 2, we went over 1 and up 2. So this is 1 and this is 2. Angle we're looking for is always the inside angle next to that, next to the origin. I have to find my hypotenuse, so a squared b squared equals c squared. Remember, this is always my c. So it'd be 1 squared plus 2 squared equals c squared. And you get rad 5. So that's my hypotenuse. All right. Let's do sine to save for time. So sine of theta of this would be opposite of hypotenuse, SOHCAHTOA, so it'll be 2 over rad 5. Like that. Okay, the next one, this is what I want to show you with this one. So -8 and -15. So same idea, we'll draw a little triangle. We'll just do -8 over here and -15 down there, because it really does not matter. Right, once we get our point, -8, -15, how do we make a triangle? Well, we always go to the x-axis. We always go to the origin. That makes a right angle. And we should note this, and this is the angle I'm looking for. And we should know two of the sides. This side, we went left 8, so negative 8. This side, we went down 15, so negative 15. If I want to find my hypotenuse, I'm going to have to do quadratic Pythagorean theorem. So negative 8 squared plus negative 15 squared equals c squared. And if we simplify this, we get 64 plus 225 equals c squared. So 289 equals c squared. Square root of that, and I don't know what the square root of that is. So we'll just leave it like that. Now, why did I bring this side up? Because we did two of these already. I want to point out that the hypotenuse is never negative. It's a distance from here to the origin, and distance is not a negative number. So no matter where this quadrant that is, hypotenuse is always positive. So it's positive here, because yeah, we're in the first quadrant, makes sense. Right over here, hypotenuse is positive because it was on the top part, makes sense. Notice how this was negative because you went to the left. It's a normal XY chart. You go up, positive, you go to the right, positive, you go left, it's negative, you go down, it's negative. So that was the only thing negative. Over here, everything should be negative, but not the hypotenuse. Hypotenuse is the distance, so it's always positive. And if we wanted to do, I don't know, let's say cosine of our angle, that would be so TOA, so we adjacent over hypotenuse. So negative 8 over radical 289. So like that. How about the next one, 0, negative 4? So here's x, here's y. 1, 2, 3, 4. And when it's like that, when it falls on a line, there's a special name for that. You cannot make a triangle. So a lot of people do this. I'm like, where do you do that? Like, a lot of people give me this. Like, where does that come from? There's no other point there. There's only one point, so you can't do that. What you're supposed to do is, this is a special angle. It's called a quadrantal angle. And you don't make a triangle. We'll talk about how to solve it right now. So if it falls on a line, we call that a quadrantal angle. There's a different way to solve those. So first, what is a quadrantal angle? Well, it's any angle that falls on the x or y axis. So there's only four possibilities, right? You're on the x-axis, you're on the y-axis, which is 90 degrees. You're on the other side of the x-axis, that's 180 degrees or pi, and then you're down here on the negative y-axis. So you're 270 or 335 over 2. Those are called the quadrantal angles, and we solve them a little differently. The way we solve them is a little bit like this. Let's talk about our triangles again. Right, so when we have a triangle like this, you might have noticed, so if we have a point x and y, x was this side, y is this side, and then our radius was this guy. Well, when we did cosine of our angle, we got, so TOA, x over r. When we did sine of it, we got y over r. Okay, opposite of hypotenuse. And then tan TOA, opposite of adjacent, is y over x. So this is what we have to remember when we do quadrantal angles. If it's a quadrantal angle, this is the key. Cosine is x. Sine is y. And tan is sine over cosine, or y over x. Now, how to remember this? I remember sine is sine. Sine's the y value, sine. And what does that make cosine? The x value. There's only two values, sine and cosine. Well, cosine and sine go together, right? And there's an x and a y. So if I remember sine is y, cosine must be x. And then tan is sine over x. Sine over cosine or y over x. So that's how I remember it. Sine. It's dumb, but it works for me. So I know sine is always y, and then cosine must be x. If we're doing a problem like negative 2, 0, and I wanted to find the cosine of that problem, well, my x value is negative 2. Now, how do you find the radius? Well, radius, when you have a quadrantal angle, normally you do a squared plus b squared c squared, but when you have a quadrantal angle, the radius is just the value they give you. Look at it. That's the radius. That's how long the function is. So if I have the point, negative 2, 0, the way we're going to do this, remember radius is always a positive number, would just be, what's my x value? Negative 2. And what's the radius? Remember, radius is always positive. It's the distance. So it would be absolute value of negative 2, which gets me negative 2 over 2, which is negative 1. So cosine of negative 2 over 0 of that point is negative 1. Okay, now let's apply that to the unit circle. So how would I find the following? Sine of 3 pi over 2 and cosine of pi over 2. Cosine of pi. Well, step 1 is we graph it. Here's 0, here's pi, here's 2 pi over 2 and 3 pi over 2. Now keep in mind we're doing the unit circle. So what that means is the farthest out we go is 1, 1, negative 1, and 1. Now I would like to point out this is a normal xy graph. Like you get a normal xy graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's all we're looking at, but we're just zooming in at the right here at the unit circle. So it's a normal xy graph. We're just super zooming in on the unit circle. Now where's 3 pi over 2 at? It's on the unit circle, so it's right here. We have to know that point. It's a normal xy graph, so we went down 1, so that point is 0, negative 1. What's the sine value? Sine is sine e, it's a y value. The y value here is negative 1. So there's my answer. Sine of 3 pi over 2 is negative 1. You might be asking, what about the r? It's a unit circle. My r here are just 1. That's the length of it, because it's a unit circle. So you just got to figure out literally the x or the y value. If I did cosine of pi over 2, we'll do that in blue. Cosine of pi, do that in blue. Where's pi at? Well, I have a picture ready right there. Here's pi. That point is negative 1, 0. Cosine's the x value, so negative 1. So that's how you figure out trig values at the unit circle on the quadrant if it's on a quadrantal angle. If it falls on one of the quadrantal angles on the axes, you do it a little differently. Cosine is x, sine is y, and tan is y over x. Okay, so before we get into doing the unit circle with radians, we already did this with degrees, we need to know how to draw in standard position. So let's practice with these. Pi over 3. So if when we draw a radian degree, we start with radian chart. We start with 0 and pi. This is halfway. This is halfway between these two. So this is 3 pi over 2. Now the trick was anytime it's a 1 on top, the coefficient's a 1, it's in the first quadrant. So automatically first quadrant. Done. There's my angle. How about this one? 5 pi over 6. So here's 0, here's pi, pi over 2, 3 pi over 2. My tricks of drawing anything else that's not a 1 on top is common denominator. So this guy is over 6. Here's the pi. It's a 1 pi. You can make that anything you want. So we're going to make it 6 over 6. Right? 6 over 6 is still 1 pi. Now remember, when you draw an angle, if it's positive, you go up. So we're going this way. Well, I haven't got to 6 over 6 yet. We're at 5 pi over 6. We're a little short. So we're like right here. We're in the quadrant right before. So 5 pi over 6 would be over here. 5 pi over 6. Which is the angle from our starting point to where we get. 7 pi over 6. Same idea. Here's 0, here's pi. That's all I really need right now. Now again, we talked about this in the last video, but this right here is where we start. We always start at the 0, the positive x-axis, and we go counterclockwise if it's positive, and we go down if we go up if it's positive, we go down if it's negative. Clockwise or counterclockwise. So we're going to use the same trick. 7 pi over 6, we're going to make this 6 over 6. What would 7 pi over 6 go if we're going this way? Well, it'll go a little past 6 over 6 to the next quadrant. 7 pi over 6. That's the length from here to here. Now, again, graphing these things will become very important in radians. And once you get used to the fact that, okay, it's over 6, 6 over 6. It's over 4, 4 over 4. Let's make life a lot easier. Next one, we want to sketch the angle and find the reference angle. Well, remember, reference angle is the distance from that to the x-axis. But one of the benefits of doing radians is, once you know what the denominator is, you know what the reference angle is. It's always the same. So pi over 4 is always going to be 45. Because remember, pi is essentially equivalent to 180, as you could tell from our graph here. Right, pi is where the 180 would be. So it's like 180 divided by 4, which is 45. So again, no matter what you have on top, if it's over 4, it's 45. Likewise, over 3 is 60, and over 6 is 30. Right, so it's like 180 divided by 3, which is 60, and so it's like 180 divided by 6, which is 30. And the k just tells you what quadrant you're in, but if that's the denominator, I know the reference angle. So here, 3 pi over 4, sketch the angle, find its reference angle. I know the reference angle is already. It's over 4. It's automatically 45 degrees. That's the reference angle going to be. But let's back to sketching. Here's 0, here's pi. How do I sketch? Right, the key is you make this a 4 over 4. Because that's what I need, because that's what my base is. I think this is a positive 3 pi over 4. It might be a negative, but positive, we'll treat it like a positive 3 pi over 4. That means we're going up. This is 4 over 4, but we're going to be a little short. So we haven't reached there yet. So we're in the quadrant behind. So we're right here. And this angle from here to here is 3 pi over 4. Okay, next one, 11 pi over 6. Like I said, I already know what the reference angle is. It's over 6, so it's automatically 30. That's my reference angle, but let's draw it to practice. So here's 0, here's pi. I'm actually going to need to go to 2 pi in this case. You might ask why? Well, again, it's 11 pi over 6, so this is going to be 6 over 6. Well, what does that mean? What would be right before it if we're going positive? Right before it that we didn't reach would be 5 pi over 6. What about right after it? 7 pi over 6. I gotta get to 11, so what that means is this. We went halfway, we got 6 over 6. If we go another halfway, it's 6 over 6 plus another 6 over 6, which gets us 12 pi over 6. By the way, if 12 pi over 6 is the same thing as 2 pi. 12 divided by 6 is 2. So this would be the same thing as 12 pi over 6. If we're going this way, a little short of 12 pi over 6, we're at 11 pi over 6. We haven't reached this yet, so we're a little short. So this is 11 pi over 6. Right, from here to here is 11 pi over 6. And the reference angle we made is 30 degrees. By the way, I should have done it here also. Remember, the reference angle always goes to the x-axis, so that's this guy. That is 45 degrees. Okay, the next one, negative 7 pi over 3. So a couple things here. Again, it's over 3, so I already know it's going to be a 60-degree angle because of since it's radians, we know what it is. It's a negative, so we're going to have to go down, not up this time. So here's 0, here's pi. Here's 2 pi, so I think we have to go around. So negative means we go down, not up. So we're going this way. So this is going to be, same trick, we use the same trick we did before. This is 3, so we'll make this 3 over 3. So down here it's 3 over 3. One less would have been 2 pi over 3. One more would be 4 pi over 3. But I gotta get all the way to 7, so we're going to go around and then around again. So this would be 6 pi over 3. Which, by the way, would be 2 pi, right? 6 divided by 3 is 2. So 3 over 3, another 3 over 3 is 6 pi over 3. I get to 7. Now again, we're going down because it's negative. So negative 3 over 3, negative 6 over 3. If I was a little short, it would be 5 pi. A little past it is 7 pi. Remember, we only ever add 1 or subtract 1. So go to 3, 1 less would be 2, 1 more would be 4. Go to 6, 1 less would be 5, 1 more would be 7, which is what I want. So graph one like this. This is 7 pi over 3. And our reference angle is 60 degrees. Because it's automatically over 3. Okay. We need a couple more things before we can actually evaluate unit circles at radian measure. Now again, I don't care which way you do this. The way I do it is using special right triangles. Remember how we do in degrees? It's the exact same concept. So I can treat them as 3 separate triangles. There's a 30, there's a 60, and there's a 45. I know 30, 60, 90 triangles are the exact same triangle. I think it helps to think about like separate triangles. So these visualize separate triangles. Now, this is just something you have to memorize. 30 is the smallest angle, so that gets the 1. X is 31. Right? Hypotenuse is 2. Actually, on all of them show hypotenuse is 2. This will be adjusted in a second. But 30 is the biggest angle, so it's a 1. That's a 2, so the missing side is rad 3. Over here, we have a 60. That's a big angle. It's the biggest angle we have. So obviously that's the rad 3. Rad 3, 1, 2. So that's a 1. Remember, 3069 triangle has 1, 1, rad 2 in it. The 3069 triangle, you have 1, rad 3 and 2 in it. Right, so if it's 3069 triangle, you should have 1 rad 3 and 2. And that's the way it goes. Small angle gets the 1, big angle gets the rad 3, 2 is always hypotenuse. In a 45-45 90 triangle, the ratio is 1, 1, rad 2. 2 is always in the hypotenuse no matter what. So if it's 1, 1, rad 2, this has to be the radical 2. Also, it's 45, 45, so the two sides that match are the 1s. Alright, because the 45, 49, 59 triangle. So 1, 1, rad 2. 30, 60 are a little different. 30 is small, gets the 1. 60 is big, gets the rad 3. Okay, now that we have that, we know that we could solve the trig function using radians. Right? Here's the steps. Exact same as we did degrees. Graph the angle in standard position. Make a right triangle with a reference angle. Fill out the triangle using the right triangles. Then use SOHCAHTOA to find the value. So let's do our first one. Sine of pi over 3. So we're going to draw a triangle in standard position. Remember, when there's only one on top, it's automatically in the first quadrant. So let's draw a triangle in the first quadrant. Right? So again, let me just draw an angle first in the first quadrant. There's my angle, right? First pi over 3. You always want to go to the x-axis, never to the y. So you either got to go up or down to the x-axis. And you make a right triangle. The angle you're trying to find is always the inside one. Now it's pi over 3. So I should automatically know the reference angle. That's the key thing about radians. When it's over 3, it's automatically 60 degrees. So I already know what this triangle is. It's 60 degrees. And that tells me everything I need to know, right? If that's 60, opposite to rad 3, hypotenuse is 2, and adjacent to 1. So sine is going to be SOHCAHTOA. So it's going to be opposite of our hypotenuse. Done. And that's all we do. Just like when we did degrees, but now we're doing radians. Next one, we'll do some more. Sine of 3 pi over 4. So we're going to do a little faster. Here's 0, here's pi. Right, first thing we do is got to graph it. So this is 4, so we make this 4 over 4. It's positive, so we're going in this direction, but we're a little short. We haven't reached 4 over 4 yet, so we're going to be in quadrant 2. Make your angle. Remember, make a triangle with the x-axis. Has to be the x-axis. The fact that it's over 4 means we should know what the reference angle is. It's automatic. It's over 4, it's going to be 45. And now that you know it's 45, you should know the sides, right? The 45, 45, 90 triangle. So it's 1, 1, rad 2. And then, well, you went to the left, so it says negative. You went up, so that's positive, and hypotenuse is always positive. I want sine again, so we're going to do SOHCAHTOA. So opposite of hypotenuse. 1 over rad 2. If you want, you can rationalize it and you get rad 2 over 2. Which is also very common to use. Next one, tan of 5 pi over 3. So we're going to graph it. Here's 0, here's pi. So the trick is make this 3 over 3. Right, so we're going 0 to 3 over 3. Now remember, the way it works is 1 less is 2, 1 more is 4. So I need to go around again. I went here, I got to go around again. It's 6 pi over 3. Also known as 2 pi. And since we're going this way, it's positive, we're going up, 3 over 3, going back, 3 over 3. We're a little short. It's going to be over here somewhere. I don't need this anymore. So there's my angle. Bad angle, I know. You always go to the x-axis. Make a right triangle. Angle is on the inside, the one we're looking for. It's over 3, so it's automatically 60. We have to have those memorized. Over 3 is automatically 60. That means I know the sides. Opposites, rad 3. Because 60 is big. Hypotenuse is always 2, and my adjacent is 1. Now, since we're moving right, so right is positive, down is negative, so it should be a negative rad 3. Now we're doing tan, TOA. Here's my angle. Opposite would be rad 3, and adjacent would be 1. So negative rad 3 over 1. Now, if you don't like is it negative because it went right or down or anything like that, there's another way to do it, which is all students take calculus. This tells you where everything is positive at. That's what this is. This is a sign chart for trig. It tells you where everything's positive at. So A stands for all. Everything's positive in quadrant 1. S stands for sine. Only sine is positive in quadrant 1. T stands for tan. C stands for cosine. And again, this is telling you where stuff is positive. So let's break it down. We're going to skip these. So I need to talk about this. So sine. Where is sine positive? Well, it's positive in A because everything's positive in A. And it's positive in S because that's what S stands for, sine. So sine is positive on top, which makes sense because sine is the y values, and y values are positive on top. If they're positive on top, then it must be negative on the bottom. Cosine. Right? Where's cosine positive? Well, in quadrant 1, because they're always positive in quadrant 1, and cosine, C stands for cosine, so quadrant 4. Again, if it's positive on these two, it must be negative on these two, which again makes sense because cosine is the x values, and x values are positive on the right and negative on the left. Tan. Where is tan positive? Well, at A, because they're all positive at A, and at quadrant 3, because that's where T stands for, and negative at these two. So that's the sine chart. And you're like, how does that help me? Well, if you go here, and you don't want to do like, what is the negative because it went up or down? Look at what quadrant you're in. All students take calculus. We're in quadrant 4. Only cosine's positive in quadrant 4, so you know tan must be negative in quadrant 4. Like the one we did over here, right? We're in quadrant 2. And we're sine. Quadrant 2 is right here. Sine is, that's where S stands for, so it's positive. So our answer should have been positive, and it was. So 2 ways to tell what the sign is. Either understand when you go left or down, it's negative, or do all students take calculus? That's the way to remember it. All students take calculus. Fun mnemonic to remember what the things are. Okay, let's do a couple more. Sine of 13 pi over 6. So we're going to graph it. Here's 0, here's pi. We're going to make that 4 over 4. Now I'm going to go all the way to 13. So remember this way this works. You go to 4, a little less is 3, a little bit more is 5. Go around again, you get 8 pi over 4. So a little less is 7, a little bit more is 9. So we're at 4, 8, go around again, 12 pi over 4. And remember, since we're going this way, so it's 4, 8, 12. A little short would be 11. A little bit more would be 13. So it's in quadrant 3. That's all that's the only thing that matters. It's in quadrant 3. Then we do the same thing we always do. We make a triangle. This is the angle we're looking for. It's over 4, so it's automatically 45. And I should let them know the sides. 45 is 1, 1, rad 2. Right, because it's 45, 45, 90, so these are the same, and you have a rad 2 has a hypotenuse. Sine, SOHCAHTOA, so opposite over hypotenuse. 1 over rad 2. Now if you notice, I didn't do the sine, I didn't do like, oh, did I go left or down? I'm going to do this using the sine chart, using the sine chart. So, all students take calculus. We're in quadrant 3. Well, the only thing in quadrant 3 that's positive is tan. We are not tan, so our answer must be negative. So that's how it works. Now again, it works if you understand it's the concept of when you go left it's negative, when you go down it's negative, hypotenuse is always positive. So my answer would also have been negative 1 over rad 2. So either way it works. Let's do cosine of negative pi over 3. So here's 0, here's pi. It's a negative pi, so we're going to go down. So when we go down, we go here. Remember, the trick is make this common denominator, so we'll make this 3 over 3. So we're going down this way. This is 3 over 3. We haven't reached it. We're at 2 over 3, so we're going to be 1 short. So we should be in the quadrant before. So right here. After I do that, the rest of it should be the same. You make a triangle with the x-axis, always with the x-axis. Your angle is always the inside angle. It's over 3, so in radians it has to be 60. It's like 180 over 3. Once I have that, I know what all the sides are. Opposite 60 is rad 3. Hypotenuse is 2, and the adjacent side is 1. Right, hypotenuse is always 2. 60 is the big angle, gets rad 3. There's another one where I'm not going to do the sides, I'm going to do the sine chart instead. So, we're doing cosine, so SOHCAHTOA, so adjacent over hypotenuse, 1/2. Now if I want to know if that's positive or negative, we're just going to do a sine chart. All students take calculus. We're in quadrant 3 again, so which means only tan is positive, so that means everything else is negative. We are cosine, so we are negative. Again, if you don't like that, you could also do the other thing where, like, if you just know your sides, you went to the left, so that's negative. You went down, so that's negative. Hypotenuse is always positive. We are negative 1/2. So either way works. Okay, last thing we're going to do. So what's going to happen here is they're going to give us a trig function, like a fully filled trig function, and it gives us a quadrant. And we have to find the other 6 trig functions. Now, for the sake of time, let's say we're going to find sine. Okay, so how do we do this? Well, we use this guy to build a triangle in that quadrant. So you want to build a triangle in quadrant 4. So we're going to do a couple of these. So here's my triangle. Here's my xy plane. Well, remember, we want to build a triangle in quadrant 4. So quadrant 1, 2, 3, 4, we're over here. Now we always build triangles the same way. We go out from the origin, and we go up to the x-axis. And this is the angle we're looking for, right? It's always the same thing. Angle we're looking for is always the inside angle. We always make a right angle with the x-axis. What do they tell us? Tan is negative 2/3. So tan is negative 2/3. What is tan? TOA. So opposite is 2, adjacent is 3. So my triangle here, opposite side, which is this guy, is negative 2. And my adjacent side is 3. So if I want to find sine, I need sine needs opposite of hypotenuse. So I got to find the hypotenuse. Do quadratic formula. Start Pythagorean theorem. Right, a squared plus b squared equals c squared. There's currently no hypotenuse, so that's my c. I'm going to get 9 plus 4 equals c squared. 13 equals c squared. So radical 13 equals c. So there's my hypotenuse, and now I can find all 6 trig functions I want. Now in this case, I said let's just find sine, which would be opposite of hypotenuse, which would be opposite of hypotenuse. Negative 2 over rad 13. So that's the idea. We'll do one more just to make sure we got this. Cosine theta equals negative 8/17 in quadrant 3. So again, we're going to do the same thing. We go, okay, we're in quadrant 3. So that's this quadrant. We'll build a triangle, so we go out from the origin and go up to the x-axis, or down to the x-axis. This is the angle I'm looking for. And then we're going to use this to fill out the sides, right? So we know cosine is ka. So adjacent for hypotenuse, which makes this 8/17. So my adjacent side should be 8. Again, it's my angle, so it makes this opposite. So this is 8, this is 17. Right, you can figure out the missing side is by doing Pythagorean theorem. A squared plus b squared equals c squared. Now, this is one of the sides, so it doesn't matter which one it is, but the hypotenuse has to be 17. So 8 squared plus b squared equals 17 squared. We square all these. This is 64 plus b squared equals 289. Subtract 64. B squared equals 225. Square root b equals 15. Now to plus or minus, technically I took a square root, so it's a plus and minus 15. So like that. Now, again, you could, if you know the sides, you should know that this is a negative 8 and that's a negative 5. You went left, you went down, and that's always positive. But it actually doesn't matter. Let's do what we always do. Let's figure out, I already found sine, so let's find another one. Let's find tan. We'll do tan of theta, right? Well, you have your triangle. What's tan? TOA. It is opposite over adjacent, so it's going to be 15/8. I just got to figure out the sine for 15/8. What's one that always works? The sine chart. All students take calculus. We're in quadrant 3, so my thing is in quadrant 3. That is tan, so only tan is positive. Hey, I'm doing tan, so 15/8 is positive. Everything else would be negative. And that's the idea.